Hi, I'm Philip Hahn.
I'm Max Palmer.
I'm Dylan Potter.
And I'm Dana Sharak.
The topic we desire to introduce to y'all today is about the U.S. airport travel, especially how the quantity of passengers in 2022 significantly impacted the business of an airport and its effects on transportation security, administration, and wait time.
So this is our introduction. Aviation is an essential mode of transportation because it provides the fastest worldwide transportation network that we have so far, that makes it vital for global businesses and tourism. After COVID-19 kind of ended and all of the lockdowns shut down, flight industry skyrocketed, and the number of passengers to that of December 2019 kind of fluctuated. The aviation sector drives the U.S. economy by carrying 853 million passengers, supporting 9.5 million jobs, which accumulated 1.25 trillion to the U.S. GDP in the past, and it grows businesses. As of 84% of Fortune 500 companies are within 20 miles of an international airport. So with more passengers and a greater supply of passengers, the greater demand is placed on TSA. So the problem of our team's desired is to solve how the business of an airport, U.S. international airport specifically, is affected by the wait times of passengers and vice versa.
So, why do Americans feel that waiting in line is torture? Well, according to the New York Times, the experience of waiting is defined by the objective length of time. For instance, occupied time feels shorter than unoccupied time. So that's why hotels place mirrors in elevators. There's a lot of impulse buying in grocery stores. Without being notified of wait times, stressful passengers are uncertain if they will make their flight in time. Overall, people are really concerned with line length rather than the speed. So that's why Disney kind of wraps their line attractions around buildings and overrides wait times so that people who wait less than expected leave happier. According to Zid Cameron, our memories are influenced by those final moments. So that's why people are happier when they get to this security. But the greatest influence of waiting is fairness. Passengers will always be fixated on the pre-check line because that's the line that's beating them. And did you know that Americans spend roughly 37 billion hours each year waiting in line? That's pretty crazy.
So what motivates us? So why do we want to solve this problem? So our team desires to improve the efficiency of airport security through displaying wait times that will enhance our passengers' happiness levels. When passengers are more cheerful, the overall airport experience magnifies, and the more passengers tend to flock towards those airports, which increases both aeronautical 57% and non-aeronautical 47% revenues. On the larger scale, tourism generates economic growth and revenue as visitors spend money with the community's business. Cumberland Valley, Pennsylvania.
So our method to start, we determined specific airports scale from large hubs, medium hubs, and small hubs. Most large hubs utilize a central point for coordinating flights to different spokes. We then collected big data regarding the number of passengers from Wikipedia and the daily wait times from the TSA wait times into an Excel spreadsheet. While in the spreadsheet, we computed daily averages for the wait times for each specific airport, parsed the data into Python, and programmed using two data science approaches: user interface and simulation and modeling.
So which airports did we choose? We chose US-based airports on their classifications, just because we thought that would be the best strategy to use going forward. We chose these based on the number of passengers they had, with large hubs such as Hartsfield-Jackson, which is the busiest airport, which contributes to 1% annual commercial passengers. We also chose medium hubs such as Kansas City, which contributes to 0.25% to 1% of annual commercial passengers, and small hubs such as Fresno Yosemite, which contributes to 0.05 to 0.25% of commercial passengers.
Thus, how does our code work? Well, first we import Python libraries, and then we parse the different sheets. So we parse the airport and passenger statistics, which contain the airport's list, code names, number of total passengers, and number of daily passengers. And then the sheet 2 and 3 we parse that data for the average wait times. And then lastly, we extract the statistics for each airport. And here's an example of such. We extract the name, size, code, number of gates, the average daily TSA wait time, and the max TSA wait time and corresponding time.
So then for our user interface, our code applies the main function with two function definitions. Input airport passes the airport names and codes to print a list of the airports with their 3-digit codes, explains all the callable statistics, and collects a user's 3-digit code that they input. And as the name implies, print STMTS prints the airport statistics, airport name, size, annual passengers in 2022, daily passengers in 2022, maximum wait time with time of day, and average wait time for the user. To run the program, the defined functions are called.
So after we use the user-defined function to do any of the user input and interface stuff like that, we also have a simulation and modeling section. So our second data science approach involved this modeling. We have a multi-bar chart explaining the correlation between daily passengers and the corresponding TSA wait times. And then we also have a second plot, which is a line graph with a quartic regression of the daily average wait times among airports, just based on the size of the airports. And these are just shown to display our second data science approach.
The intended use by the client is for the client to gain knowledge about each airport statistics, especially wait times through the user interface. Our models try to show the correlations between the number of passengers and associated TSA wait times relevant to 2022, and specifically 2022. The client can expand upon our programs to include statistics for multiple airports and different years.
So what are some insights and challenges that we have? The daily TSA average wait times are not dependent upon the number of passengers. The most of the large hubs expect more passengers, and some of the small hubs expect the less passengers. But those medium hubs can expect a passenger amount, so that's why their wait times fluctuate. The New York Liberty International Airport has the greatest daily TSA average wait time at 14 and 3/4 of minutes, and Kansas City has the least daily TSA average wait time at 3.67 minutes. Well, the fluctuation of wait times across airports varies. According to our TSA Press Secretary Jenny Work, these wait times fluctuate since no airports are the same, even with the same setups. There's a different footprint for each airport at different checkpoints. Some challenges of our program was compiling, importing, and parsing the data for each airport, and also placing those wait times by hour into lists. Finally, it was difficult to generate the output for the user's input, but through a certain amount of time, we kind of got that code up and running.
And here is a video of our code.
And a matplotlib, and then it parses the data based upon the different sheets. So the sheet 1 contains the airport statistics, such as the total passengers, daily passengers, size, gates, and then code names. And then the second sheet contains the data of the average wait times per the airport. So we can run that. And then after, it parses the individual data for each individual airport through indexing values. After that, it does for all 20 airports. It parses those into different arrays. And then we have two function calls in this main function. One retrieves the airport code from the user, and then the other uses that airport code to print some statistics that is given to it. So if we run this code, we have a list of airports, and we're chosen the statistics that it will give us. So if we chose like one of the busiest airports, code names such as Atlanta, we will receive statistics about the number of passengers, daily number of passengers, and all those statistics, including the maximum wait time and the time taken. The last part of our code is the data simulation and modeling. One of the plots the U.S. international airport codes against the descriptive statistics for TSA wait times and the number of passengers. And then our last model plots the model line of the TSA wait times over time in order of decreasing passengers or decreasing capacity of passengers. And
And here are our sources and all of our pictures that we used.